Welcome back to the new session on conjoint analysis. This time we are going to take a statistical approach, in particular a linear regression approach. Just to recall, the last session was on taking an optimization approach to solve the conjoint analysis problem. What were the specific details of that optimization problem? Remember, we had that example of 5 products which were detailed on 2 attributes. And remember that the attribute values were almost continuous. Remember, we had values like 1.5, 2.3, that kind of a thing. In the optimization approach, the attribute data, the product property data, you can say, product features data was almost continuous. The consumer choice data, if you recall, the consumer choice data was pairwise data. We asked the consumer between the pair JK, what do you prefer? And we recorded the ordered pair JK, right? These are some of the things that we are going to change and look at the statistical approach. So if you have, so what does that mean to a manager? If you have the product data on a continuous scale and you have collected consumer choice data only in pairwise approach, you should go with the optimization method that we had seen in the previous session. On the other hand, if your data on the product properties, if your data on the product dimensions are categorical, right, and you have collected only the preference ranking data, okay, you have collected only the preference ranking data, which means that you had 5 products, product variant 1, product variant 2, product variant 3, product variant 4, and product variant 5. You did not ask the consumer to give their preferences pairwise. You only said, out of these 5 products, rank them. Okay, rank them. And then the consumer said, you know what, looking at all the product dimensions, product number 4, I will rank number 1. Product number 2, I will rank number 2. Product number 3, I will rank number 3. This is 4 for me and this is 5 for me, right? So consumer is ranking the product or consumer is rating the product, right? I will explain what is the difference. So I will say this is 10 on 10 for me. Probably this is 8 for me. This is 7 for me. This is 5 for me, and this is 3 for me. So when the consumer is ranking the products, obviously smaller number means better product. On the other hand, when the consumer is rating the product, we are generally going to say that higher the rating, right? 10 on 10, right? On a scale of 10, I am giving the product 10. That means the product is 10 on 10 for me. So higher the rating, the better the product is. After 10 is 8, right? 8 is the next preferred product. So the consumer choice data is also not collected pairwise. Consumer choice data is collected for the rating. So let us go with ratings, because we can always convert ranking to a rating, right? We can always do that. So let us not do this also. Let us do this. So when is the linear programming approach used? Linear programming approach is used when the consumer choice data is pairwise data and the attribute values are continuous. Linear regression approach is going to be used when the consumer choice data is ratings and the product attribute data is categorical, right? Need not always be categorical, but essentially we want the consumer choice data to be on a rating scale. We don't want pairwise comparisons when we are trying to use regression. It so happens that this is actually the most traditional method of running conjoint analysis, right? And it is just a multiple linear regression, right? And we have seen multiple linear regression. So really this session is not going to be about describing the multiple regression output, even though there are some tweaks to the multiple regression model, but the focus is not on regression. The focus is trying to get insights about our conjoint analysis that has been run through the regression problem. So for the regression problem, we are going to say that the consumer rating data, this is my dependent variable. This is my Y, right? This is the response variable. So consumer essentially responds to whole bunch of attribute values and gives me a rating. So rating value is the dependent variable. Ratings value as a dependent variable, and all the attribute data, right, characteristics on the product, which is attribute data, are all my independent or predictor variable, explanatory variables, right? Once again, let us not get into the debate of whether I should be calling that as independent variables, because sometimes they are not independent, they have correlation, and we have seen what happens, right? Multicollinearity and all that we have seen. So let us say that they are explanatory variables. So attribute data is the explanatory variable, and the customer's rating data, respondent, we are going to call that customer as respondent because they are the ones who are responding to our choices, our options. Right, so that is going to be the dependent variable, right? So here the betas, the regression coefficients, have a special interpretation. We are going to actually call them utilities. We are actually going to call them as part worth. Right, we'll come to that a couple of slides down the line. We are going to talk about part worths. So we are going to definitely focus on the interpretation of the regression coefficients, which are the betas for this regression model. So pay attention to that. So let us actually, obviously, we are going to check whether the regression itself is significant or not using our typical indicators. R squared is going to help us. The p values are going to help us. The squared error, the standard error is going to help us, right? RMSE is going to help us. So all those typical indicators of whether the regression itself is good or not will be checked, but the focus is going to be on this beta. Okay, focus is going to be on this beta because that gives me very important piece of information, which is called part worths or part utilities. So let us look at the Excel, right? So what example do we have? I have constructed. So this is a completely hypothetical example. I have constructed this example. This is not from any textbook. This is not from any one of the online resources. And most importantly, this is actually not a survey that was conducted, right? This was simple hypothetical example that was created for the purpose of this session. So I have an example of a cell phone and the choices for cell phones. So what kind of things we look at when we buy a cell phone, when we buy a mobile phone? Typically, I look at a brand, right? Who is the manufacturer? Samsung, Xiaomi, right? iPhones, and so on. OnePlus. I may be. I may want my cell phone to last longer. Therefore, I may be interested in powerful battery. Today is the world of selfies, so probably I am interested in having a very good front camera. So camera resolution is important. That too, front camera resolution is important. I'm talking about selfie generation. There may be many other attributes, but I have looked at these three. Right? I have looked at these three. So the hypothetical example that we are going to show now has data on choices for brand, choices for battery sizes, and various front camera resolutions. So in particular, we have considered three brands to choose from, 2 battery options, and 3 choices for camera resolution, right? For that, I looked at the cell phone data, cell phone sales data in India, and for my hypothetical example, I selected some of the better selling mobile brands in India, right? Same is true for battery options. I have tried to choose the popular battery options, and I have tried to choose popular front camera resolution options. So what is going to happen in a conjoint analysis? So how many choices are there? There are 3 brands multiplied by 2 battery options multiplied by 3 camera resolutions. So 18 options that you can build, 18 options that you can build by permutation and combinations of these attributes. We are going to show all 18 attributes. Remember, for the optimization problem, we said how many choices exist. We said n into n minus 1 divided by 2, right? So there were 5 products. We were asking consumer for pairwise choices. Therefore, we had to ask consumers n into n minus 1 divided by 2. So 5 for 5 products. So 5 into 4 divided by 2. So we had to ask consumers 10 choices. Here we are going to ask consumers to choose or rate or rank 18 options, right? This was 10 pairwise comparison. This is 18 direct ratings to be provided. 18 direct ratings to be provided. That was for only 5 products. Actually, using these combinations, you can construct 18 products. You can construct 18 products that the consumer has to provide rating for. There were only 5 products which had values on 2 attributes. So 10 pairwise choices question, right? Do you prefer this or this? Do you prefer this or this? Do you prefer this or this? We ask that question 10 times. Here we are directly going to show the products. And how many products? 18 different products constructed out of 3 brands, 2 options of battery and 3 choices of camera resolution. I will show the data in a minute, right? So we are going to consider what is called as a full factorial design. In a full factorial design, the consumer gets to see all the possible combinations, right? All the possible combinations, and then they have to provide, as we decided, they are not going to provide rank, they are going to provide ratings, right? But we know that there is a strong association. If I know the rank, I can actually ask the consumers to give me a rating on a 10 scale or something like that, right? A lower value of rank means most preferred product, higher value of rating means more preferred product, right? And obviously, as we decided, we are going to go with ratings. So let us look at the Excel. Let us look at the Excel. Stopping the PPT now and showing the Excel. So this is the data. This is the data. So these are the options. As I said, there are 18 options. There are 18 options constructed from 3 choices of brand. What are the brands that we have selected? Samsung, Vivo and Xiaomi. These are the 3 brands available. There are 2 battery sizes, 4500 mAh, right? Battery is usually in mAh, right? That is the unit. mAh. So 4500 is one choice, 6000 is the other choice. So there are 2 choices for batteries, and there are 3 choices for the front camera resolution: 20 MP, 13 MP and 8 MP. Okay, 20 megapixel, 13 megapixel and 8 megapixel. So fairly powerful front cameras. Right? I don't know whether these combinations exist in the market. I have constructed them. I told you this is a hypothetical example. And therefore, using combinations of these options, I can actually create 18 different products. So Samsung with 4500 mAh battery and 20 MP camera is my option number 1. Samsung with 4500 mAh battery and 13 MP camera is option number 2, and so on, right? Xiaomi, there are the 3 models of Xiaomi with 4500 mAh battery. There are 3 options of Xiaomi with 6000 mAh battery. There are 2 options for not Xiaomi, Vivo. There are 3 options of Vivo with the 4500 mAh battery. There are 3 options of Vivo with 4500 mAh battery. Similarly for Xiaomi, there are 2 options of Vivo with 20 MP camera. This is one option, 20 MP camera, which has 4500 mAh battery. 20 MP camera, which has 6000 mAh battery. Right, so 2 options for 20 MP camera, 2 options for 13 MP camera, which is this 4500 and this 6000 for Vivo, right? So accordingly, there will be product options created. So this is the data that I show the consumer. This is the data that I show the consumer. I show this consumer options for 18 products, and I ask the consumer, give me your rating. Give me your rating. So clearly, consumer says that a Samsung with a 4500 mAh battery and 20 MP camera, the preference rating, right? So this is rating. This is rating value. Rating means on a scale of 10. This is a scale of 10. Let us write that also, on a scale of 10. And obviously, higher the rating, the more preference for that particular product. So apparently there are 2 products which have received 10 on 10 ratings. One is this product. So consumer says option number 10, which is a Vivo cell phone, 6000 mAh battery and 20 MP camera. Also Xiaomi with a 6000 mAh battery and 20 MP camera was rated 10 on 10 by the consumer. There are other ratings also. What is the next rating? 9 was the next highest rating. Samsung 6000 mAh battery and 20 MP camera. Obviously, you know, these are our typical choices. We want more powerful battery, we want amazing front camera. So the ratings for higher resolution for camera is going to get higher ratings. Right. So similarly, 7 consumer rates Vivo which has a 4500 mAh battery on a 20 MP front camera resolution is rated as 7 out of 10. Right. There are lots of sevens though. Lots of sevens. Xiaomi with a 6000 mAh battery and 13 MP camera was also rated 7. Xiaomi with a 4500 mAh battery and 20 MP camera was also rated 7. Right, these are all ratings provided by the consumer. Ratings provided by the consumer. Obviously, people don't like low resolution camera and weaker batteries. So Vivo with a 4500 mAh battery and 8 MP camera was rated only 2 out of 10. This was even worse. Samsung with a 4500 mAh battery and 8 MP camera was rated only 1. Right, so this is rating on a scale of 10. So this is my response data. This is what consumer responded with for the 18 choices that I provided to the consumer. Right. So this is going to be coded as my response variable, the y variable. These are going to be my explanatory variable. But look at this. Here, explanatory variables are categorical variables. They are not continuous variables. They are not like 1.5 and 2.3 that we had on the attribute values when we looked at the optimization problem. Right? So this is categorical data, right? I mean, here you can't even rank the brands. You may want to arrange the batteries either as 4500 first or 6000 first, right? Similarly for front camera resolution, the way I have done. Either go from top to bottom in terms of number in terms of pixels available, or go from bottom to top in terms of pixels available, right? So whichever way you look at it, this data is categorical data, which means that I will have to code it before I built a regression model out of it. So let us explain that coding. So what we are going to do is let us code the data. Let us put some numbers there, because I really can't run regression with names like Samsung here. If I run the regression with 4500 and 6000, the regression is going to treat this as a continuous variable. However, it is not, right? Similarly for front camera, right? We don't want it that way. So let us say that Samsung is going to be called brand number 1. Vivo is going to be called as brand number 2, and Xiaomi is going to be called as brand number 3, right? So one way of putting a number there, we are going to call 4500 mAh battery as number 1, 6000 mAh battery as number 2, right, and so on. So 4000, wherever you see one here, that means 4500. Wherever you see 2 here, that means 6000 mAh battery. Similarly, the last piece of coding is for front camera resolution. Let us put 20 MP as number 1, 13 MP as number 2, and 8 MP as number 3, right, corresponding to these 3 values. And preference data hopefully is not changed at all. It is the same. That is the response provided by the consumer. I am only trying to code the input data. Let us define variables that should go into the regression model. Let us get that. So now I am defining binary variables. This kind of definition still doesn't help me, we are not going to go with Samsung recorded as 1 and Vivo recorded as 2, right? Let us not do that because that is still confusing. Let us define binary variable for brands. So I am going to define 3 binary variables for brand. X1 takes on a value 1 or 0. X1 is 1 if the brand is Samsung. So how do you define X1? Let us go here. Let us add an Excel sheet. Let us add a blank sheet. Right? How do you define X1? So X1 is equal to 1 if brand is equal to Samsung. Okay, is equal to 0 otherwise. How do you define X2? X2 is 1 if brand is Vivo and 0 otherwise. X3 is 1 if brand is Xiaomi and 0 otherwise. So this is how I define a binary variable, one for each brand. So I get 3 variables just for the brand attribute. Similarly, I will define X4 is equal to 1 if battery size, spelling is incorrect, battery size is 4500 mAh, right, and 0 otherwise. So binary variable. X5 will be 1 or 0, 1 if battery size is 6000 mAh, 0 otherwise. Okay, so that's how we will keep defining the binary variables, and these binary variables will now be used in regression equation. Now this is something different from what we had looked at in the regression models that we had seen earlier. So as I said, 3 binary variables, one for each brand. So X1 is 1 if brand is Samsung, X2 is 1 if brand is Vivo, right, and X3 is 1 when brand is Xiaomi. You have to ensure that you don't have 2 ones in these rows. There is only one 1. Here there is only one 1 which is for column number D, which corresponds to Vivo. Here there is only one in each row corresponding to row E, which corresponds to Xiaomi, right? So binary variable, one for each brand. Similarly, binary variable, one for each battery size. So X4 is equal to 1 when battery size is 4500 mAh. X4 is 1 if battery size is 4500 mAh. It is 0 otherwise, right? Clearly in this case X4 is 0, that means the battery size is not 4500. So what is it? It is defined by X5. X5 is 1 when battery size is 6000, 0 otherwise. Okay, so these are the 2 variables, these are the 2 binary variables that we define for battery size, and again these are the 3 variables that we get to define, one for each front camera resolution. So if the front camera resolution is 20 MP, X6 is equal to 1. X6 is equal to 1 if the front camera resolution is 20 MP here, 20 MP here, 20 MP here, right? So 1, right? 1 was coded as 20 MP, 2 was coded as 13 MP, 3 was coded as 8 MP. So wherever you see 1 here, X6 should be 1. X6 is 1 when you have 1 here. You have 1 here, so X6 should be 1. When you have when you have front camera which is not 20 MP, X6 will be 0. Here X6 is 0 because the front camera resolution is number 2. Number 2 is 13 MP. Here X6 is 0 because the front camera resolution is coded 3. What is 3? 3 means 8 MP. Right. So X7 is defined exactly for 13 MP. X7 is 1 when the front camera resolution is 13 MP. So there is a 1 here, 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 and so on. Right. And we have done that kind of coding for all the 18 product options that we have shown to the consumer. Okay, hopefully this variable, now what we have done, we have actually defined the variables that we are going to use in our regression model. X1, X2, X3, X4, X5, X6, X7, X8, right? We have defined these variables. Let us remove this. We don't need this kind of coding now. 1, 2, 3. We are not going to use 1, 2, 3 coding. We are not going to use 1, 2 coding. We are not going to use this 1, 2, 3 coding for brand. So let us remove that and keep the coding, right? So now I have removed that. So now I have only variables, right? Hopefully that go into my regression equation. X1, X2, X3 are for brand, right? These are for brand. X4 and X5 are for battery, and X6, X7, X8 are for front camera resolution. In all this, I have not touched the preference data because preference data comes from the consumer. What I am playing with right now are trying to code my attribute levels using binary variables. Now you see a problem here. What is the problem here? What do you not want in a multiple linear regression? we had discussed earlier when we discussed another application of multiple linear regression, we don't want multicollinearity. What is the situation of when does multicollinearity happen? When the explanatory variables are correlated. Now, do you see correlation amongst the explanatory variables? Can you notice correlation amongst the explanatory variables? Okay, let me tell you that. If I tell you that x2 is 0, x3 is 0. If I tell you that x2 is 0, x3 is 0, what am I telling you? I am telling you that x2 is 0. What does that mean? x2 is 0, that means your brand is not Vivo. x3 is also 0. What does that mean? If x3 is 0, you know that the brand is not Xiaomi. So what do you mean by this? Not Vivo, not Xiaomi. Essentially that means it has to be Samsung. So if I tell you the value of these two variables, if I tell you the values of x2 and x3, you can clearly tell me that x1 will be 1. So there is a strong correlation, right? Essentially that's what it means. If these three variables were independent, the values of x1 should not have any bearing on the value of x2, should not have any bearing on the value of x3. Here I am telling you, if x2 is 0, x3 is 0, you can say 100% x1 is 1, because you know that there are only 3 brands. So if the brand that you are showing to the consumer is not Vivo, x2 is 0, not Xiaomi, it has to be Samsung. So x1 will be 1. Right, so you can't have that. Remember this is even more pronounced. Here x4 is 1. Right, x4 is 1. x4 is 1 means that the battery size is 4000 mAh. The battery capacity, we have been calling that as size. It is not size, battery capacity. Right, battery capacity is 4500 mAh. Right. If I tell you that x4 is equal to 1, means battery capacity is 4500 mAh. You know that x5 is going to be 0. You cannot have x4 is equal to 1 and x5 is equal to 1 at the same time. Battery capacity cannot be 4500 mAh and 6000 mAh at the same time. So knowing the value of one explanatory variable, you can clearly tell me the value of the other explanatory variable. You don't want this situation. Right? Whatever happened for x1, x2, x3 is actually going to happen for x6, x7 and x8. If I tell you that x7 is 0 and x8 is 0, the moment you know x7 is 0, you know that the front camera resolution is not 13 MP. If you know x8 is 0, you know that the front camera resolution is not 8 MP. So not 13 MP, not 8 MP essentially means that the front camera resolution is 20 MP, because you know that there are only 3 options. If it is not 13, not 8, it essentially means it is 20. So knowing the value of the two explanatory variable tells you completely about the third variable here amongst these 3 variables x6, x7 and x8. This is a strong indication of collinearity, very strong indication of collinearity, which is not correct in a multiple linear regression model. So what do? How can we remove this multicollinearity from our regression model? What we are going to do is, from each of these groups, first group is x1, x2, x3 because it represents brand. Second group is x4 and x5 because it represents battery capacity. Third group is x6, x7 and x8 which represents front camera resolution. From each of these groups, we are going to remove one of the variables. So let us say from here we remove x1. Let us highlight that. We'll remove this x1. From this we will remove x4. From this, let us remove x6, or let us remove x8. Let us remove x8. Okay. So I have removed one variable from each of the groups. Does that actually affect my output of the multiple linear regression? We are going to later on show that it actually doesn't. However, it does help me, right? It does help me, because since x1 is not in the regression equation, now there are only two. Now when x2 is 0, it is not necessary that x3 has to be 1. x2 is 0, x3 can be 0, or x3 can be 1. x3 can be 1. So when x2 is 0, I have no automatic choice that x3 has to take a particular value. x3 could be 0, x2 can be 1 or 0. x2, look at this, all these values, look at this value, look at this, right? x3 is 0, x2 can be 1, which happens in all these cases, or x2 can be 0 also. So whatever we can say about x2, we can say that about x3. So knowing the value of x2 does not automatically tell me about anything about x3. So we have removed that collinearity, right? We have removed that collinearity. Now x2 is 0, x3 can be 0, or x3 can be 1. Similarly, when x3 is 0, x2 can be 1, or x2 can be 0 also. Similarly, x5 is 0, right? x5 is 0. There is only a single variable there. x5 is 0, x5 is 1. But we know, we can interpret, right? When x5 is 0, we know that x4 is 1. But x4 is not going to be explicitly included in the model. So, similarly, x8, we have removed x8. Now, when x6 is 0, x7 need not always be 0. x7 can be 1. But there are cases where x6 is 0. Let me find that case. x6 is 0, but x7 is also 0. So knowing the value of x6, knowing the value that x6 is 0 does not automatically tell me that x7 is 1 or 0. Right? x6 could be 0, x7 could be 1 or 0, and vice versa. Right? So we have removed that very strong association amongst the explanatory variables. Now let us spend very brief moment on the variable that was removed. We have removed essentially the brand Samsung, the battery size 4500, and the 8 MP camera. Okay, and the reason was, well, this was fairly, we could have removed Vivo and we could have removed Xiaomi also, right? But this becomes the base value then. This becomes the base value. And therefore, when we talk about betas, we are going to highlight that for these three attribute levels, Samsung, 4500 mAh battery and 8 MP camera, this attribute level is going to be coded as giving a utility of 0. So this becomes the base utility, and you calculate other utilities only as a deviation from this utility, right? So in that sense, you don't get the direct utility values, you only get the relative utility values, where Samsung is coded as utility 0 and Vivo's utility is going to be quantified as utility from Samsung, right? And the other way around. So so let us remove this, and this becomes my final coding. So I have removed x1 from here, I have removed x4 from here, I have removed x8 from here. The reason for removing x8 and not x6, we could have removed x6 also, and that would not have made any difference to our regression equation. The reason for removing x8 and not x6 was this was a lower sized camera resolution, and in general it is expected that consumer would prefer higher resolution resolution front camera. Therefore, what we have essentially removed is being consistent. We removed the lower size, lower capacity battery, so we removed the lower resolution camera. But the results would not have changed that much. The interpretation of results would not have changed even if we had removed x6 instead of x8. But this is my final values now. I have removed x1, I have removed x4, and I have removed x8. So this is my final coding, and this is the final data that I am going to use for my regression model. Okay. In all this, please note that I was only playing with the binary variables. I have not touched the preference data. Preference data comes from the old sheet where the actual data was collected from the consumer on the 18 options. That data is still intact when I am trying to run the regression now.